Hello everyone, welcome back to my YouTube channel. I am Bhumika, currently pursuing in third sem in the Department of Computer Science and Engineering at Sri Venkateshwara College of Engineering, Bengaluru. Today I am going to explain the topic of a review of logic gates and its applications. Mr. Bhavit Garg and Mrs. Sukhmanit Kaur are authors of this research paper. Abstract. In this paper, we have discussed different types of logic gates and corresponding logic tables. The base of any digital computer systems are logic gates or circuits which performs logical operations on chunks of information represented digitally. Logic gates work on the basis of binary digits 0 and 1. Any intelligent system with the abilities to take decisions comprises of simple logic gates. This paper is an attempt to bring forth the application of digital logic gates in day-to-day life with some real-time applications as well as like burglar alarm and security system. Through the study of number of physical systems, example, mechanical, optical, electrical, thermal, biological systems, it can be said that modeling of any such system can be done logically with the help of Boolean expression. Accordingly, such a system can be studied mathematically. This paper is a generic effort in understanding the Boolean mathematics behind the physical system around. Introduction. The word logic itself gives us an idea that they work on certain kind of logical operations. Logic gates are the integral part of digital mathematics. A logic gate is a device performing an elementary Boolean function producing a logical 0 or 1 output depending on one or several such logical inputs. Implemented with either electronic, optic, mechanical, or even biological devices, logic gates can be composed into physical models of all conceivable algorithms or computation. Generally, for every logic gate, we have only one output, but in case of inputs, it may vary. But for the logic gate called not have only a single input and single output. Logic gates are the building blocks of digital circuits in which diodes and transistors are used to perform switching functions. By combining thousands of millions of logic gates, it is possible to perform highly complex operations. A truth table helps us to show the function of a logic gate. It shows the output states for every possible combination of input states. Now we will discuss about types of gates. First one, AND gate. An AND gate receives A and B, where A and B are bits and produce output denoted by A dot. Here we can see the diagram and truth table of AND gate. OR gate. The OR gate receives inputs A and B, where A and B are bits and produce output denoted by A plus B. Here is the diagram and truth table of OR gate. NOT gate. A NOT gate receives input A, where A is a bit and produces output denoted by A. The NOT gate is shown below. You can see. NAND gate. NOT AND gate is equal to an AND gate followed by a NOT gate. The outputs of all NAND gates are high if any of the inputs are low. The symbol is an AND gate with a small circle on the output. The small circle represented inversion. The NAND gate is shown below. NOR gate. NOT OR gate is equal to an OR gate followed by a NOT gate. The outputs of all NOR gates are low if any of the inputs are high. The symbol is an OR gate with a small circle on the output. The small circle represents inversion. The NOR gate is shown below. You can see. Exclusive OR gate. This is also called XOR or EOR or EXOR gate. The exclusive OR gate is a circuit which will give a high output if either but not both of its two inputs are high. An encircled plus sign is used to show the EOR operation. The EOR gate is shown below and truth table also. Exclusive NOR gate. It is also called XNOR or ENOR or EX-NOR gate. The exclusive NOR gate circuit does the opposite to the ER gate. It will give a low output if either but not both of its two inputs are high. The symbol is an EXOR gate with a small circle on the output. The small circle represents inversion. The ENOR gate as shown below. Applications. The applications of logic gates are mainly determined based upon their truth table, that is, their mode of operations. The basic logic gates are used in many circuits, like a push button lock, like activated burglar alarm, safely thermostat, and automatic watering systems, etc. Digital communication cannot happen without logic operations. Daily life application of EOR and ENOR gate can be related to ladder switches used in homes or can be found in water level checker circuits. AND gate. AND gates are used to combine multiple signals. If all the signals are true, then the output will also be true. If any of the signals are false, then the output will be false. ANDs are not used as much NAND gates. NAND gates use less components and have the advantage that they be used as an inverter. AND gate is used in security alarm. For example, security alarm system. OR gate. Whenever the occurrence of any one or more than one event is needed to be detected or some actions are to be taken after their occurrence, in all those cases OR gates can be used. For example, doorbell system. NOT gate. NOT gates are also known as inverter because they invert the output given to them and show the reverse result. Now the CMOS inverters are commonly used to build square wave oscillators, which are used for generating clock signals. The advantages of using these is they consume low power and their interfacing is very easy compared to other logic gates. For example, NOT gate based on heating concept. NAND gate. Device failure alarm system. When all the fans are working, the input to the NAND gate is 1 and the output is 0. If any one of the fan stop working, the output of the NAND gate becomes 1, which activates the alarm. Burglar alarm. When the switch is closed, one input of the NAND gate is low. When the LDR is in the light, the other input is low. This means that if either of these things happen, that is the switch is closed or the light is on, one of the input is low. The output is high and the buzzer sounds. Freezer warning buzzer. When the thermistor is cold, its resistance is large and the input to the NAND gate is high. Since the NAND gate is connected as an inverter, the output is low. As the thermistor warms up, its resistance decreases. The voltage across it falls and the input to the NAND gate falls. When it becomes low enough, the output becomes high and the buzzer sounds. NOR gate. Washing machine controller. A washing machine has three sensors to check for washing machine lid open, washing tub filled to minimum level and weight of cloths and water in the tub. If the machine lid is open or the water in the tub is below certain level or the machine is overloaded, the output of the corresponding sensor is set to 1, producing a 0 and the NOR gate output that switches the machine off. Conclusion. Logic gates are fundamental building blocks of digital electronics and computer systems. They are responsible for processing binary inputs to produce desired outputs based on Boolean algebra. The basic gates include AND, OR, NOT, NAND, NOR, XOR, and XNOR, each performing a unique logical function. By combining these gates, complex circuits can be created, enabling the design of digital systems such as computers, smartphones, and more. Logic gates are essential components in digital electronics, enabling basic binary operations that form the foundation of more complex circuits and systems like computers, calculators, and processors. They are vital for performing computations, decision making, and data processing in modern technology. Thank you for watching. Please do like and subscribe to my YouTube channel.